Alright, so today we're going to introduce the idea of graphing on a coordinate plane. And as we get through this, we're going to see that there's a lot of language in here already. So graphing, we're really going to try to move towards, it's a picture of solutions to an equation. So if we give an equation, we want to see what the solutions look like, we call it a graph. Coordinates are ordered pairs. So those are traditionally going to be x and y values. And then the plane is a two-dimensional space. So a piece of paper is a plane, the whiteboard is a plane. That's different than space where we have three dimensions. So we'll look at some examples, some terminology, but things to keep in mind as we move forward here about what a graph is, what coordinates are, and what the plane is. Alright, so if we look at the coordinate plane, we basically take two number lines, one going horizontally and one going vertically, and we put them together at the point 0 and 0. So we put those two number lines together. We call the one that goes horizontally the x1, the one that goes vertically the y1. And then when we put those together, instead of just dividing our area into two sides, the up and down or the left and the right, we now get four things called the quadrants. So we can see those are our two number lines put together. And we have the one in the upper right corner is called quadrant 1, and then we go counterclockwise to get quadrant 2, quadrant 3, and quadrant 4. And where they meet, that point in the center, is called the origin. That's where everything starts. So just like the origin of species, that's where things start. So we start counting from 0, 0 always. We have to label our x and y axis in terms of scale. That's what we count by. So if we look at the top one here, I'm counting by ones, so my scale is by ones. Now often our x and y axis are scaled the same, but it doesn't have to be. So I could count by ones on the x axis and count by 5s or 10s or whatever on the y axis, as long as I count by a consistent number for each axis. Alright, so let's look at some examples. So I want to identify the coordinates. Well, I find point A, and I see I go over 2, and then I go up 1. That means for my ordered pair x, y, I go over 2 for the x value and up 1 for the y coordinate. So that's the point 2, 1. If I look at point B, I go up 4 and then over 1. So my x value is 4. My x value is 1, my y value is 4. If I look at point C, I go back 3, negative 3, and up positive 3, which is the point negative 3, 3. For point D, I go back 5, and then I don't go up or down anything. So that's my y value equivalent to being 0. So that's a point negative 5, 0. For point E, I go back 4 and down 3. And for point F, I don't go anywhere left or right, so my x value is 0, but I go down 2, so that's the point 0, negative 2. And my last one, I go over 5, negative 4, and we can see that I go over 5, I go down 4. There's my point 5, negative 4. Now if I wanted to see which points are in the quadrants, I need to think, let's look for a second at what happens with the quadrant. So in the first quadrant, I go positive x, positive y. Second quadrant, I go negative x, positive y. Then I go negative, negative, and then I go positive, negative. So if I look down at the example, negative 5, 7, I could plot it, but I could notice I'm going to go back and then up. That puts me in quadrant 2. The point 0, 6, I don't go anywhere in the x coordinate. I don't go anywhere x value for 0, and then I go up 6, that's on the y-axis. Back 2 and down 3 is negative, negative, which puts me in quadrant 3. Back 4 and up 0 leaves me on the x-axis. Over 1 and up 8 puts me in the first quadrant, and over 5 down 2 puts me in the fourth quadrant.